Hi guys, today I am going to explain the mechanical principles which are applied on the orthosis or hand splinting. As you know that hand splints or hand orthosis are prescribed for different purposes. Those splints or orthosis must perform the function efficiently, as well as the splint should be durable and it should be comfortable also for the patients. So various principles are utilized by the therapist or by the professionals who fabricate those splints. These are the mechanical principles which are basic principles of the physics, like principles related to the first order lever system, or related to torque, or related to relationship between the force and pressure, etc. So today I will discuss the principles which are followed while making the or fabricating the splints, and specifically the mechanical principles. The first principle is the application of basic force system. The basic force system which are applied on the orthosis or hand splint are 3-point pressure system. 3-point pressure system are the system where there are reciprocal forces, 3 reciprocal forces: proximal reciprocal force, distal reciprocal force on the splint, and the middle reciprocal force. All these forces are alternatively opposite to each other. The middle reciprocal force is the sum of the proximal reciprocal force and the distal reciprocal force. So and another force system which is applied is the 2-point pressure system, where multiple opposing 2-point pressure forces are there, and these type of forces are seen usually in coaptation type of splint, which are mostly non-articular type of splint, while 3-point pressure system is utilized in the articular type of splints. Now the second point is the increase the area of force application. Why do you want to increase the force application? Because it will reduce the pressure from the soft tissues, particularly skin or bony prominences. Now how you can increase the force application? It is by using the wider area of the splint. Means it should be optimally lengthened. This splint should have length of optimum length. Second point is the edges of the splint must be rolled out. Otherwise, the straight edges, they put pressure. So if you roll out, the force application will be increased and the pressure will be reduced. Third is if you are using the material or whatever material you are using, particularly it is easily applicable in the cases of low temperature thermoplastic material. It is to confirm the bony prominence, or you may provide a contiguous fit over the bony prominence. So that will also help to reduce the pressure from the bony prominence. Now third principle is increase mechanical advantage. Why do you want to increase the mechanical advantage? This mechanical advantage term you must have studied in your lower classes, maybe 8th class, 6th class, 7th class, which is applicable to lever system. So in lever system, as you know, when you increase the mechanical advantage, it is easily the machine can be used for lifting a heavy weight easily. So same way in this splint also, if you increase the mechanical advantage, it will help to reduce the pressure from the skin or soft tissues, and the durability will also be increased. So how you will increase the mechanical advantage? It is definitely by reducing the resistance arm, or by increasing the force arm. How you will increase the force arm, which is easier? That is, the force arm is, in case of a splint, is the, for example, forearm trough. So if you increase the forearm trough up to the 2/3 of the forearm length, then it will reduce maximum of the pressures and you will increase the mechanical advantage. Second option with you is to apply the straps of the splint. Straps are applied to the splint to anchor the splint on the body part. So in that case, you apply the straps as far as distal and proximal on the splint. Then those splints will also have greater mechanical advantage where there is a where you can reduce the resistance arm. So these all features will help the splint to increase the durability as well as to increase the comfort, or in another sense reduce the pressure from the soft tissues and particularly skin. Fourth principle is the using of optimum rotational force. So rotational force are sometimes applied to move the joint or to stretch the joint, to increase the mobility of the joint, to increase the range of motion of the joint. So in that case, the rotational force is applied with the help of mobilization assist and outrigger system. Mobilization assist is applied to a particular point in the outrigger system. The mobilization assist is actually anchored at a particular point on the outrigger system. So mobilization assist have some elastic component, some spring component, or some material having elasticity, and a finger cuff in case of finger. So this mobilization assist is utilized to mobilize the joints to increase the range of motion by either stretching it or by providing the assistance to the weak muscle group. So this force must be optimum, means as much as little or as much it is required, optimum force. So when you give the optimum force, the direction of application must also be kept in the mind. It should be 90-degree angle on the bone which is going to be moved, or 90-degree angle to the axis of that joint for which that bone is attached. So for example, if you are attaching the mobilization assist for mobility of distal interphalangeal joint, so the application of the finger cuff should be at 90-degree to the distal phalanx, as well as it should be applied 90-degree to the axis of the distal interphalangeal joint. So this will help to avoid any damage to the secondary joint, means which is not involved in the splint or which is normal. This will also avoid any push or pull on the proximal joint. This will also be helpful to avoid any stretch over the collateral ligaments of the joint. Now, fifth principle is you will have to consider the torque effect. As you know, what is torque? Torque, as a physics formula of physics, torque is the factor of force and distance from the axis. So when you apply a, say, finger cuff, according to the strength of the person to pull against the elasticity of the cuff, depends upon that you will place the finger cuff nearer to the joint or farther to the joint. If you place nearer to the joint, the patient need less force to pull it against the elasticity, or if you place it little distal to the bone, then it will, with the same force, with the same elasticity, the patient will feel more resistance to pull that. So depending upon the strength and weakness of the opposing muscle group, this torque effect, the principle of torque effect, is applied in mobilization assist, where there is a rotational force. Now, sixth point is the consideration of relative degree of passive mobility of successive joint. What does it mean? Means all the joints which are interlinked to move a part of the body. For example, in case of finger, a metacarpophalangeal joint, proximal interphalangeal joint, distal interphalangeal joint, these are all three successive joints in case of hand. Suppose all these three joints have similar range of motion. So in that case, the whole of the finger can be splinted together. But suppose in these two joints, only one joint is have minimum range of motion or few degrees of range of motion, while other joints, say proximal interphalangeal joint and metacarpophalangeal joint, have normal range of motion. In that case, what you will do, you will have to immobilize the proximal two joint and keep the force applied for mobility through mobilization assist at the distal interphalangeal joint. Why? Because the distal interphalangeal joint has less range of motion because of stiffness. So this principle should be applied. Such type of adjustment should be made. If this principle is not followed, then what will happen? The effect of force will be distributed. Means all the joints it has to move. This force has to move all the three joints. So the effect of force will be distributed, and the exact effect what you want on the affected primary joint will not be available. And second point, the unwanted movement which are not required which, at the normal joint, they will also be available on the secondary joint, and which may cause the damage to the secondary joint. Seventh point is control reaction effect at secondary joints. Sometimes because of not following the previous principles, the chances of damage may also develop on the secondary joint. Like if you are applying the force on the distal interphalangeal joint, the proximal interphalangeal joint, which is normal, may also have developed some damage which may not be seen immediately, but in the long term, say after a few months or few days, the damage may be seen. And damage in the sense of what? Damage in the sense of instability of the joint, because undue pressure is placed on the secondary joint, although it was normal, but the ligaments are under continuous stress, resulting into loosening of the ligaments and resulting into the instability in the joint. To avoid this, what to do? The secondary joint should also be kept in a close packed position. For example, what is the in case of metacarpophalangeal joint, what is the close packed position? Close packed position in the metacarpophalangeal joint is the flexed position. So what is close packed position? Close packed position is the position of a joint in which the collateral ligaments are completely in taut status. So that is the close packed position. Opposite terminology is the open packed position or loose packed position. In the loose packed position, what you will get? The joint can be moved. The joint, for example, in case of metacarpophalangeal joint of finger, if you keep the finger extended, you can rotate it at the metacarpophalangeal joint, passively rotate it. But if you flex the metacarpophalangeal joint at 90 degree, you cannot rotate. Why? Because the collateral ligament has become taut in this position. While in extended position, the collateral ligaments are in lax position. That is why you are able to rotate it. So whenever such situation appears, to avoid the secondary joint from any damage, the secondary joint must be kept in a close packed position. Another method to avoid such type of damage to the secondary joint is to use circumferential pressure over those joints. Means keeping the joint in a close packed position, as well as adapting some phalangeal bar to so that the pressure will is circumferential from all the sides on that joint. So that will also keep the joint in keep the movement restricted at the joint, and this will help in avoiding damage to the secondary joints. Now, eighth principle is considering the effects of reciprocal parallel forces. As I told you in the first principle, there are three reciprocal forces in a 3-point pressure system. This principle is applicable to that only. So, and I also told you that middle force is the summation of the two forces, proximal and distal reciprocal forces. So it means the middle forces always have higher magnitude than the proximal force or than the distal force. So it means proximal middle force may result, because it has higher magnitude, it may result into the breakage of that point where it is applied in the splint. So it will reduce the durability. So what you need to do, you need to keep that area little bit reinforced by adding more material at that location, or using the material of a higher thickness particularly in that area, or attach that part in that area separately. For example, if you are using a splint having a outrigger system with mobilization assist, so outrigger system at the joint with the wrist bar, there will be middle reciprocal force. So middle reciprocal force may cause damage, crack, or even the outrigger system will break from that location. So what is required? That location should be reinforced by adding other material. This is one. Second thing, by reducing the pressure. As I told you earlier in earlier principles, that you can reduce the pressure by various methods, like using optimum length, by using the optimum width of the forearm trough, by rolling out the edge of the splint. Those principles will be applied. The next principle, ninth principle, is using the appropriate outrigger system. Outrigger systems are usually two types which are used: high profile outrigger system and the low profile outrigger system. In the high profile outrigger system, the length of the elastic or spring is higher or more than the low profile. That is the only difference. So it means if you are using the lengthy, comparatively lengthy elastic or lengthy spring, it means the pull will be reduced. So for weak muscles, against weak muscles, the high profile splint is better. For the stronger muscles, low profile splint is better. It is the as per the condition of the patient, it may be decided whether you will provide the high profile splint or a low profile splint. Next principle is using the articulated component properly. What does it mean? Suppose your splint is articular type, and in articular type you will have definitely a joint, artificial joint in the splint. So for whatever part of the body you have utilized that joint in the splint, that joint must overlap the axis of the anatomical joint. Means when the person will wear the splint, for example, if you are using the wrist joint, artificial wrist joint, in that splint, and you have given that splint to the patient, and patient is using that splint, the artificial wrist joint which you have fabricated must overlap the axis of the anatomical wrist joint. Then only the splint will function properly. Otherwise, what will happen if this will not be followed? Then what will happen? This if there is non-alignment with the axis of these two joints, artificial joint which you have fabricated and anatomical joint over which this joint will be there. So what will happen? It will cause the friction. The function will also be hampered. Friction will be developed between the skin and the splint, and also shear forces also developed on the articular joints. Now next principle is to increase material strength by providing contour. As I told you, only reinforcement is not the answer for strengthening that particular location. That location can also be strengthened, or you can say that this reinforcement may not be applied at every location. So another method is to increase the durability, or in other words, to increase the strength, is by contouring the splint over the especially bony prominences. For example, in cases of forearm, the ulnar tuberosity is the bony prominence. If the splint is covering that area, that point of splint must be contoured over the ulnar tuberosity. This will help to increase the durability. And secondary part is you can increase or you can keep the optimum thickness. You can use the optimum thickness material with the optimum thickness, more applicable in cases of low temperature thermoplastic splint. Next and the last point is under mechanical principle is eliminate friction. How will you eliminate the friction? By avoiding poor fitting, proper measurement and fabrication, and proper padding will help you to avoid poor fitting. Improper joint alignment, if it is there, then you will have to correct that. You will have to keep a watch. There should not be improper alignment. Then only you can reduce the chance of friction. The fastening devices may also cause friction. So proper fitting of fastening devices, commonly straps, and sometimes this if you don't avoid this friction, then what will happen? It will result into the irritation of the skin, damage to the skin, blistering to the skin, so and discomfort to the patient. So these are the all 12 principles which come under the mechanical principles. While fabrication of the splint, you will have to follow all these 12 principles, or you have to keep in mind all these 12 principles while fabrication of the splint. Then only you can give a properly fit, comfortable, durable splint or orthosis to a patient. I think I am clear in explaining my mechanical principles which are followed in the splints. In the next video, I will talk to some other principles of the splint. With this, I conclude. Thank you very much.